Chapter 4, Episode 1 is about atoms. According to the atomic theory, atoms are the smallest particles of matter. They cannot be divided into smaller particles. They also cannot be created nor destroyed. Again, that's the first postulate of the atomic theory proposed by John Dalton in 1803. Now, again, he thought of atoms as something like this. So I cannot divide this atom into smaller particles. But of course, we now know that this is not true. We can still divide atoms into its parts, and these are your electrons, protons, and neutrons. So we also call these particles as the subatomic particles of an atom. Electrons are negative, protons positive, neutrons are neutral. Neutral means it's not negative, it's also not positive. In terms of their mass, protons approximately 1, neutrons approximately 1, electrons are very, very small. Their mass is almost 0. Now, in terms of their location in the atom, so here the protons and the neutrons are in the center, and we call this center as the nucleus. So, as we can see here, the protons and the neutrons are in the nucleus, and the electrons are around the nucleus. Now, on your table of elements, you have there the atomic number and then the mass number. This number will tell you the number of electrons, protons, and neutrons. The atomic number is equal to the number of protons. So in this case, we have atomic number 2. This means we have 2 protons in this atom. So 2 protons will give a charge of positive 2 because again, each of the proton have a charge of positive 1. So in this case, we have positive 2 coming from the 2 protons. Then next, the number of proton is equal to the number of electrons. If we have 2 protons, we also have 2 electrons. So again, we also have 2 electrons on the outside of the nucleus, and that will give a charge of negative 2. Now these charges, positive 2 from the protons, negative 2 from the electrons, it will give a charge of 0 because again, that is positive 2 plus negative 2. They will cancel each other. So overall, the charge of an atom is neutral. Now next, for the mass is equal to the particles in the center of the atom because again, if we look here, of course, the particles in an atom are the protons, electrons, and neutrons. But here we can see here that electrons have no mass, so we can remove them from the mass formula. So in this case, the mass only depends on the number of protons and the number of neutrons. On this case, the mass is 4, but we only have 2 protons here, so the remaining numbers are coming from the neutrons. So in this case, if we have 2 protons, then the overall mass is 4, then there are 2 that is coming from the neutrons. So in this case, we have 2 neutrons, 2 protons, then dalawang electrons. So here we have an atom. So here the reds are the electrons, the greens are the protons, and then the grays are the neutrons. Here we have for the electrons, we have 4 protons. We have here apat na electrons here, then we have 5 neutrons. Again, let's start to identify this element. We can identify it if we know the atomic number. So what's the atomic number of this element? Again, the atomic number is equal to the number of protons. So just look on the number of protons. It means atomic number 4. And if you check your table of elements, that one is beryllium. Atomic number 4. And then here for the mass is again equal to the number of protons plus the neutrons. So we have 4 protons, then 5 neutrons. Overall, we have 9. So in this case, this is the symbol for this one. We have beryllium, atomic number 4, and the mass of 9. Next, we have this one, protons, electrons, neutrons. Here we have 5 protons, also 5 electrons. Then here we have 6 neutrons. Again, atomic number. So we have, again, it's equal to the number of protons. So it means atomic number 5, and that one is boron. And then again, atomic number 5. Then we also need to know the mass number of the element. Again, the mass is equal to the number of protons plus the neutrons. 5 plus 6, we have 11. So this is the conventional symbol for this element.